Okay, in this video, I will explain the theorems that are in 12.2, chord and arc, and in the next video is the exercise to explain better. Now, here we have the first word, that is chord, that is a segment with endpoint that are in the circle. That means it's going from point P to point Q. Now, this chord is PQ, how we have it, and the arc is PQ with the symbol. Careful. Always the measure of the arc, the angle will be the angle that is going to the center, like this one. If this is the chord, the arc is BC, but the angle is this angle. And the length also is the distance from B and C. Now, saying this, the first theorem that we have, or even we have the theorem and the converse at the same time. It says that if the angle AOB is congruent with COD, then the arc AB, that means the distance from A to B, is congruent with the distance D to C. Well, the converse is if you have the distance D to C is congruent with B to A, then the angles that are inside are congruent. In other words, the arcs are congruent. Now, in this one, 12.5, we have the congruence of this. It says that the angle AOB, that means the central angle, and COD congruent, that then the chord AB is congruent with CD. Now the converse is either the chord AB is congruent with CD, then the angles that open here are the same. Now this one also obvious. If the chord AB is congruent with the chord CD, then the arc AB is congruent with C and D. Very similar to the past theorem, but in this one is not talking about the central angle. This is the chord and the arc. Now the next one is a lot of theorems in this lesson, by the way. If we have in a circle, we have to we have the chord equidistant from the center. That means the chords are congruent. In other words, the distance from the center to the chord has to be perpendicular, because that is to know that the small distance to be perpendicular. It is perpendicular, and this distance is the same. Then the side of AB, it is the same. And there is another characteristic that I think is in the next theorem that says that is in the half of this. Now here we have a demonstration with this example that is in the book. It says that what is the length of RS in the circle. Now the information that we know, the distance from this point to the chord is 9. This distance is 9, and also is correct the half. Notice this. That means this 12.5 is the same that this segment, that it will be 12.5. The addition of those things is 25. 12.5 plus 12.5 is 25. And the distance, that is PR, will be the same of SR. Why? Because the distance from the center is equidistant. Now this example I will solve in the other video, but it's very elementary to understand. Now here we have something different, that is the perpendicular bisector. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord at its arc. In other words, If AB is a diameter, how we know that it's a diameter? Because cross the center. And AB is perpendicular with CD, then we know first that the distance from C to this point is congruent with this point to D. Now, CE is congruent with ED, and the arc AC or CA is congruent with AD, and also D to B and C to B will be congruent. Now, here we have another one. In a circle, if a diameter bisects a chord that is not a diameter, then it is perpendicular to the chord. Now, what it says here is basically the converse of the last one. If AB is a diameter, AB, and CE, the distance from this point to this point, is congruent with ED, that means in this chord is cut in the half by the diameter. That means they are perpendicular to each other. The other one, in a circle, the perpendicular bisector of a chord contains the center of the circle. Well, if AB is the perpendicular bisector of CD, okay, perpendicular bisector cut in the half because it's bisector, then AB contains the center of the circle. In other words, AB is the diameter because to contain the center and cross the circle is the diameter. All those three theorems basically are the same. This is the thing that we will apply most often. Now here we have some examples and in the book. For example, this what is the value of each variable to understand? If we are looking for the variable r here, and we know that Lm is 14 and the distance from K to N is 3, but we know in the product diagram that this is perpendicular. Mean this important thing. This is perpendicular, that means it's cut in the half. I mean this part is 7 and this part is 7. Now here we have a right triangle with the hypotenuse r, with this leg 3 and this leg 7, because that it is used the Pythagorean term. Now in this other exercise, we have the information that says that this is 15. We don't know the distance, this is 15, and we are looking for y. But we know from this information that this segment AC is 11 and CF is 11. But notice this. This is the center, and this 15 is going to point E. That means this is the radius of the circle. We may move the radius all around the circle. Let's write it in this distance. The distance AB is the same distance to BE. How I know? Because it's the radius. Now, the right triangle that we will use here is a right triangle with the hypotenuse 15, with a leg y, and with a leg 11. That is what we have in this example. Now, I will solve in the next video some exercise that are in the book, but I will solve the exercise 14 that is in this page here. Now, as I said in the, I will say in the video, I won't assign any classwork for this one, but my recommendation is understand what is 8, 9, how you solve 8, 9, and 10, and how you solve the next exercise 13 and 15, because 14 I solved it in the other video.